Hello, welcome to Taxonomy Online Mathematics. In this episode, we want to look at this question under Calculus 3, application of differentiation. A hollow right circular cone of height 18 centimeter and radius 12 centimeter is held beneath a tap that is leaking at a rate of 2 centimeter cube per second. We have to find the rate of rise of water level when the depth is 6 centimeter. Leave your answer in terms of pi. So if we identify that this is a differentiation as application, this is going to be the rate of change, the rate at which one parameter is changing. And we have been given the rate at which the water is leaking. That's the rate of change of volume has been provided. Then we are asked to find the rate of change of water level. The water level is talking about the height, the rate at which the water level is increasing when the water itself is leaking from the tap. That is what we are looking for. So we have in mind the change, the rate of change. So first thing first, we have identified that we are dealing with what? Volume, right? You see the hollow cylinder held beneath the tap is leaking at the rate of this. Find the rate of rise. Okay, so this is talking about the volume. So we can say that the volume of a cone, this is the parameter we have in the question. The volume of a cone is given by 1/3 pi r square h. We know the volume of a cone is 1/3 that of the volume of a cylinder. So if this is what we have under differentiation, after we have identified the parameter and state the formula, the next thing to do is to perform differentiation of the dependent variable in terms of the independent variable. But in this case, 1/3 and pi are all constant. So this is r and this is h, both of which are different variables. So it means that differentiating this directly will involve implicit if there is no other information. But if you go back into the question again, let's find out the things given unto us. The height is given, the radius is given. So let's just say the height is given as 12 centimeter. The radius is given, I think the height is 18. Then this is 12 centimeter. Then when the tap is leaking at the rate, meaning the rate of change of volume is given. So dV over dt is given as 2 centimeter cube per second. So what is next? We're looking for the rate of change of what? Of the water level. Which in this case, you're looking for dH over dt. That is what you're looking for. Alright. Now, with this information, we can make a sketch of our cone, which is placed under the tap. Then we know that the height of the cone has been given unto us. The height of the cone, that is what we have as 18 centimeter. Then the radius of the cone has also been provided as, let me reduce this, as what? 12. We get that? Then the water will be dropping in, so it will be filling, rising up to a certain level, which we are not aware, so we can just indicate here. Then the height of water level, we said that we have to find the rate of rise of water level when the depth is 6 centimeter. So the depth of water in the cone is also provided as what? 6 centimeter. So we can also find the radius here, this height. If you put this together, that will give you two similar triangles. Let's pick the bigger one. The bigger one will be right angle here. So we have our 12, we have our 18, then the smaller one, let's indicate the right angle here. This is the H, and this is what? The R, right? We can see that this is a similar triangles. One is enlarged. The smaller one is enlarged to give us the bigger one. So we can find a ratio of that. So R as a radius divided by the height will be equals to 12 over 18, in the sense that we are looking for the scale factor that enlarge the smaller one to give us the bigger one, so that we can be able to express R in terms of H or H in terms of R. So our differentiation will be made up of only one variable. So here, if I multiply through by H, your R will be equals to, don't forget, 6 is a factor of 12. So we can get 2, 6 here, 3 times what? H. So this is now going to replace the R, so that the R will be in terms of H. Do you get that? So that our differentiation will not involve implicit differentiation. So our volume becomes 1/3 pi. Then R, which we are now picking as 2/3 all squared, because the R is squared, then we multiply by what? The H. So now let's put them together by simplification. We are going to have 2 squared divided by 3 squared times H squared. And H squared times H will give us H cubed. So this will be volume equals to 2 squared will be 4. 4 times 1, 4. 3 squared will be 9. 9 times 3, that will be 27. Then your pi, H squared times H will give you H cubed. I'm sure you are following step by step. As I mentioned earlier on, we are to differentiate. Now we can differentiate the V with respect to H. Direct differentiation. Therefore, our dV dH is going to be 3 is coming forward to multiply. So 3 on top, if it goes into 27, that will be 9 times. So we'll be left with 4 and 9. Don't forget the 3 came to multiply, but it's a factor of 27, so we cancel out. Then our pi will come, then H 3 minus 1, that will be left with 4, H squared. Okay, this is clear? Good. So now we have what we are looking for. This is there, this is there. The next thing is to find the range at which this is increasing, the height, which is dH dt by chain rule. Okay, let me state it. We can say that dH over dt equals to, we begin with dH divided by the next parameter, which is going to be dV, times dV over dt. Don't forget, if you look at it, the dV will be cancelling, so dH over dt. That's how the chain rule is stated. So we have the dH dt, that's what we are looking for. dH over dV must be given. So we look through. Okay, I can see dV dH. dH over dV, we can find the reciprocal of this. So in this case, we can take our dH over dV to be the reciprocal of this. So all this divided by 1 divided by that. Now, seeing this is a fraction, the 9 goes up, then we have 4 pi H squared. That is what we are having for dH over dV as a reciprocal of that. So that can be written as 9 divided by 4 pi H squared times dV dt. We have it here as what? 2. Do you get it? So the whole of this is 2. The whole of this is what we have for this. What is next? Now, we are to leave our answer in terms of pi, but h is there. So we can see that the depth is given to us as 6 centimeters, meaning the depth of water in there is 6 centimeters. So we can introduce that into it. So when h equals to 6 centimeters, your dh over dt will be, don't forget these two will cancel this already. So 2 here, 2 here, that will be 2. So I have 9 in my numerator, then 2 pi, then times what? 6 square. The h is square. Then the 6 square is going to be 36. 9 can divide 36 4 times. So 4 will multiply the 2 to give us 1 divided by 8 what? Pi. So we are saying the rate, so that will be centimeter per seconds. So the rate at which the water is rising in the coal when the depth is 6 centimeters will just be 1 on 8 pi centimeter per seconds. I believe the concept is okay by you. If you have a question, you can do that in the comment section. Share with somebody who may need this tutorial. Subscribe to the channel, and God will bless you. Bye-bye.